Question A1 on the midterm asks you to find y equals secant squared of 4 to the power of x cubed. We're going to use the chain rule, so first we should rewrite this as secant of 4 to the power of x cubed all squared. This is not necessary, but for a lot of students they find it easier to visualize, so we're going to start by bringing out the 2. So the derivative then is going to be 2, keep the bracket the same, multiply that with the derivative of what's in the bracket, so the derivative of secant is secant 4 to the x cubed tan of 4 to the x cubed, and again, next step of the chain rule, times the derivative of this part that didn't change. So in this case, that's the derivative of 4 to the x cubed is 4 to the x cubed, times the natural log of 4, times the derivative of x cubed, which is 3x squared. All we can do to simplify here is put constants, or multiply the constants together. So 2 times 3 is 6x squared. There's a 4 to the x cubed left here. ln 4 can come up front. Secant is secant squared of 4 to the power of x. 4 to the power of x cubed, and tan of 4 to the x cubed. So that's the answer for the first question. The next question is find the derivative of this function. This is another chain rule, so we're going to work from the outside in. So the derivative is the derivative of cosine first, negative 1 over the square root of 1 minus, and it's everything that's here squared. So that's ln of x squared plus 4x. That gets multiplied by the derivative of this part. So the derivative of ln x squared plus 4x is 1 over x squared plus 4x multiplied by the derivative of x squared plus 4x, which is 2x plus 4. And the only real way to simplify that is put it on top here. Doesn't really make it any easier, so we'll leave that alone and go to the final question in part 1, or part A, which is the derivative of y equals this function to the power of this function. Function to the power of a function means we have to take the natural log of both sides, and the reason we do that is to bring down the exponent. So we're going to bring the exponent down, and we can do that because we've taken the natural log of cosecant x squared. We'll put that in brackets just to isolate it. Now we differentiate both sides. The left side is 1 over y times y prime. The right side here is a product, so the derivative of the first, 1 over 1 plus 3x all squared, times the derivative of 3x, which is 3. Keep the second part, so that's ln of cosecant of x squared, plus keep the first, so that's tan inverse of 3x, multiplied by the derivative of the second, so the derivative of this is 1 over cosecant of x squared, multiplied by the derivative of cosecant x squared, which is negative cosecant cotan. Now you notice I just stuck it on top because I'm running out of space here across the screen. So it's really 1 over cosecant x squared multiplied by this, but since we're multiplying, we can just multiply it by 1 and put it on top. And again, that gets multiplied by the derivative of x squared, which is 2x. Now we need to bring the y over, because we want to solve for y prime. So y prime is this part. Not a lot of simplifying we can do. Going to leave space there because this y came over. So we need our function here. Right here we end up with 3 ln of cosecant of x squared over 1 plus 9x squared. That's plus, these can cancel here. We get 2x tan inverse of 3x multiplied by cotan of x squared. And in front here is the y that came over, but we don't want y. We want what y is in terms of x. So this is cosecant x squared all to the power of tan inverse of 3x.